All right, so we are going to be continuing with polynomials and multiplying and using models to do so. Here we have an area model and the products, and we're going to be using PolyPad to do our area models. To remind you, when we have a rectangle, okay, when we have a rectangle, and let's say this is 3 and this is 4, we know to find the area, we're going to do length times width, which the area of this rectangle would be 3 times 4, which the area of that rectangle would be 12. So this is our 3 is our length and 4 is our width. It's the same thing when we're doing with our area model. The length of this side of this rectangle is 3, and the length of, or the width of this side of the rectangle is 2x, and then this unit right over there represents 1. So each side of this section, if I were to break out these sections, is a length and a width of the triangle. So just to refresh on using our area models. And each side of those areas, the length and the width. So this 3 is our length, this 4 is our width. Same, and they represent a factor, okay? All right, now we're going to recall some information when we're talking about the product of, say, 3 factors. We know that if I have 2 times 3 times 5, I can look at, let me do my laser pointer. There we go. When I have 2 times 3, that's going to give us 6. So we're not going to do 2 times 3 and then 2 times 5. We're only going to do 2 times 3, which will give us 6. Then we're going to do 6 times 5, which is going to give us 30. Okay, so that checks out. We can also do, we don't necessarily also always have to do 2 times 3 times 5. We could switch it up. We could then say 3 times 5, which is 15. Then I have 2 times 15, which is going to give us 30. So it's going to give us the same product of those factors. I can also do 2 times 5, which is 10, which then 2 times 3, which will give us 30. The reason that this works with mathematics is because it's the same relationship with all 3 factors. And when we switch them up, there are some numbers that might make it easier for us to calculate, such as 2 times 5 is 10, and then 10 times 3 is much, in my opinion, easier to find the product of than either of the other orders of the factors that gave us the same answer. So that's going to lead us into the next situation where I have these 3 factors here. Okay, I don't just have 2 factors. I have the factor of 2, I have the binomial x plus 1, and the binomial 2x plus 3. We have 3 factors. Now, the problem is our area model over here is only our length and our width, or length and width, whichever way you want to do it. So how can we tackle this problem and put the 2 factors in our area model at a time? Does it matter which 2 you use first? No. Okay. Now we're going to go ahead and find the product. I'm going to go over here to my other screen. Give me 1 second. There we go. Excuse me there. I dropped my mic. Mic down, mic down. Okay. So we have the problem 2 times x plus 3 times 2x plus 3. Okay. And let me pan this over. Now, I can do this a couple ways. We can factor x plus 1 times x plus 3. You do have to understand that it can represent multiple ways. I may ask you, or you may be asked, to represent the factors multiple ways. The easiest way to tackle this problem in this situation would be to go ahead and distribute that 2 to the 2x and the 1. So then that becomes 2x plus 1. No, sorry, not 2x plus 1. Blah, 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 blah. That becomes 2x plus 2 times 2x plus 3. So now when I take my factors and my algebra tiles, I'm going to build my algebra tiles. I'm going to do 2x, 1x, 1x, and then I have 2 units of 1. So I'm going to bring my 1s over. Then I have 2 x's as well for my other factor on top. And then I have 3 units of 1. Now, we're going to look at the first length and width. This length is x. This length is x. X times x is going to give us x squared. We're going to look at this width. So remember, this side here is x. This side here is also x. This length here is x. This length here is x. So that means that when I do this x times this x, that's going to give us another x squared. When I do this x times this length or width of 1, that's going to give me an x, and it's positive. All of our units here should be positive because we have no negative values here, or no negative terms. Okay, we finished out that rectangle. Now we got to go down to this length of 1. All of these up top match, so I'm just going to go ahead and drag because it's literally the same as the previous row. So I'm just going to drag. Let's duplicate that, make our life easier. All right, now we're going to do this down here. So now I have a width or length of 1 and a width or length of x. So x times 1 is going to give me x. We have x. Then I have 1 times 1, which is 1. 1 times 1, which is 1. 1 times 1, which is 1. And then we have x, x, and then we have 3 units of 1. So now, how many x's do I have here? X squares I have 1, 2, 3, 4. So all of these are going to give me, and right here I have 2x, and then these right here I have 2x. Think 2x, if I were to draw a line right there and there, 2x times 2x is going to give me 4x squared. So that gives me 4x squared. I have 2x times 3. So think how many 2, if this is 3 and this is 2x, the product of this is going to give you 6x. So that's going to give me plus 6x. I have this unit here, which is 2. And then I have these, which is 4x. Okay. So 2 times 2x is going to give me that 4x. So I'm going to add that 4x. Then 2 times 3 is going to give me this section of 6 for that product of 6. Now, we got to make sure that realize that when I list these out, I have 2 like terms. So that becomes 9x plus 6, and then 4x squared plus 9x. If you notice diagonally right here and here, these two across are like terms. So that will often happen when you're dealing with your area model. Your diagonals will be like terms, and so you can combine them. If you notice that, if you don't, that's fine. We can just add up all of our x's and add all our x squares and go from there, whichever is easiest for you. Okay? Now we're going to go to the next slide. Now that we've found the product of that question, now we're going to go to this question. Now this one's a little bit different. If you notice, we have a power. Okay. Now I'm going to recall and go back to exponent rules. If I have, say, such as 2 times 3 squared, okay, I cannot just do 2 times 3. I must do and think that that is 2 times 3 times 3, which will give us 2 times 9, which will give us 18. Okay, so I must deal with the exponent first. So I can't just do 2 times x and then 2 times 1 like we did previously. So I need to make sure that I understand that this needs to be 2 and then x plus 1 times x plus 1. Now, when I get to this point, now I can distribute that 2 to one of the binomials. So this becomes 2x plus 1 times x plus 1. Just in the interest of time on this one, I'm just going to show you just using a simple basic area method. So I'm going to do length times width. I'm going to do 2x on top, and then I'm going to do plus 1. I'm going to put a plus in front of that 2x. Putting my signs just to make sure that I may keep my signs correct in case I have a negative. I'm going to do the x on the bottom and then the plus 1. Okay, notice that I blocked it off just like I would the um, polynomial pad or the poly pad. I'm going to do x times 2x, which is going to give me x times x is x squared. 2 times 1, our coefficient with x is 1. So 2 times 1 is 2. So that becomes 2x squared. We have x times 1, which is just going to give me x. X times 2x is going to give me 2x. And then 1 times 1 is going to give me 1. Positive 1. Again, look right there. We have our like terms diagonally. So technically, I can go ahead and add them up. So that's going to give me 2x squared plus 3x plus 1. Really simple and straightforward on dealing with when we have a binomial that is a duplicate or is what we like to call, to give you some vocabulary, what's to come is a perfect square binomial. And there's some special relationships that we can do with perfect square binomials, which we will get into at a later date. All right. Now, I am going to set this one up on a polypad. I do recommend that you go ahead and pause the video and see if you can figure out how this should look on the polypad, because this 4 is not technically a factor. We're just adding that 4 to the factors that we have. Now, those of you who came back or are back after trying it, you can check on how I build up the polypad. You can refresh your polypad just by hitting the refresh button. Now I'm going to go ahead and move this over a little bit, and I have x, oops, did not mean to hit that. And then I have 3 negatives. And I have another x. And again, I have 3 negatives. I could have probably just copied the other one and just turned it sideways, but that's all right. Now, on that thing, so I have the x plus 3. So to remind you, this is x minus 3. This is x minus 3. Now, I got to deal with the plus, and then I have 4 more units. So 1, 2, 3, 4. Oops. So it's kind of like outside what we have there. All right, now I'm going to do my length times width. So we have x squared. We have negative times a negative, or negative times a positive. Oh, wait, hold on. Let me do across first. So x times -1 is going to give me a negative. So I need to drag my x over here, and I need to negate it because it should be negative. And I'm going to duplicate that twice more. So we have a negative and a negative. Then again, we're going to have 3 split down as well. I'm going to go ahead and negate that and copy it 2 more times. All right, now we're not done yet, because remember, when we fill this up, when we do our area model correctly, we should have a nice little rectangle or square. So I need to do this -1 times -1. We've got to remember, in this case, we have a negative times a negative. When we have a negative times a negative, that's going to give us a positive. So the next three terms here, here, and here should be positive. We're going to go ahead and do it twice more. I'm going to go ahead and select these three ones and copy it. On PolyPad, it lets you group. So I'm going to group them, and then I'm going to duplicate my group. And then that will make my life a lot easier since I know that all of these units are going to match since this row matches the row above. All right, now we know that we have a nice little square. So now I want to think, all right, you have an x squared. You have 1, 2, 3, 4, 5, 6 negative x's. Then you have 9 ones. And then you have this plus 4 ones that you have to take into consideration. So I didn't do 9 plus 4 to simplify all the way. So that's going to be x squared minus 6x plus 9, 10, 11, 13. So our final simplified answer is going to be as such. Hopefully you got at least maybe in some concept before I went over this. If you did when you built your area model, that means you're in a really, really good spot. We're going to go to the next question. This one is dealing with the same thing. So if you notice that we still have a binomial squared and then we're adding a constant. We have a binomial squared and we're adding a constant, but now we're adding the function notation because we want to let you know that we're going from an expression to now we have an actual equation. And remember the f of x is also the same thing as y. This is vertex form to what we like to call our vocabulary that we're just first talking about is standard form. Standard form is what we've been moving towards and what we're writing in terms of our final product of the factors of the quadratics or the polynomials that we've been looking at. On this question, we're going to do the same. We're just going to do the exact same thing that we did before. I'm going to go ahead and since we're doing another step, I'm going to do it doing the little box method. We could actually technically draw this out as well. Let me go ahead and draw this one out just so that we can look at this as a drawing for the area model instead of just using the polypad. So we have a positive x. Let me make it a nice long tile. Since the algebra tiles, it's a long tile. And we have a minus 1. I'm going to fill it in. So when I shade it like that, that means it's a negative. And then we have a nice long algebra tile. And then again, I'm going to fill that in. And then we need to add the 5 positive units. All right. Now, x times x is going to give us an x squared tile. And then x times negative 1 is going to give us a negative algebra tile. Negative 1 times x is going to give us a negative x tile. Then a negative times a negative is going to give us a positive. So now I have to think here. I have an x squared. Then I have, technically I have 2 negative x's here. Because this x here and this x here, so these two x terms, that's going to give me negative x, not x squared, just x. Then I have that single unit tile. Then I have 5 more unit tiles. So 1 plus 5 is going to give us 6. Technically, we would want to write this correctly. This would become f of x is equal to x squared minus x plus 6. So this would be our equation done in function notation. Now, a way that you can check that I factored this correctly in terms of my product is we can use Desmos and put this in Desmos. And I'm going to show you how to do that real quick. Polypad. All right, so in Desmos, I'm going to put our original equation, f of x equals, and then in parentheses, I'm going to do x minus 1, and I'm going to square it, and then I'm going to do minus 5. All right, so that gives us our quadratic polynomial with my vertex at positive 1, negative 5. Now I'm going to do our new function. So I'm going to still do f of x equals, and then we said it was x squared, x squared minus x plus 6. Oh, hold on. Let's see. I did something wrong. Let me think here. Wait. This should be minus x, and this should be plus 6. It's still not working out. Hold on. Oh, there was my mistake. I have 2 of these. That should be 2x. There we go. Now I found my mistake. So this should be minus 2x. Okay, hold on. I made another mistake. Hold on. Oh, uh-oh. This should have been plus 5 on my original equation here. So I should have made that plus 5. There we go. Now they overlap correctly. There we go. I made a couple of errors there. So if I notice, so there's my original vertex form, and then now we have it in the standard form, and that overlaps perfectly. So we know that these are the correct forms for the same quadratic. They're just in different formats. One's in standard form, one is in vertex form. It is important that you know that you are aware of which form is which and how we want to talk about them. All right, and this question here is just a quick check in terms of which one would be the correct setup for using algebra tiles. All 4 of these have the correct plus. Technically, that should be a plus 5. That was a mistake.